Dr. Sridhar, back to you with another video session on DC machines. In today's video session, we are going to discuss about the principle of operation of DC machines and what are the types of DC machines and what are the major applications in especially in which areas these DC machines are highly useful. Now, in today's video session, I am going to highlight about the domestic applications, not the industrial applications. Now, if you're starting about this DC machines is a part of electrical machines. Now, electrical machines are nothing but these are one type of transducers which converts or which changes one form of energy into another form of energy. Suppose now, before starting to this, now we heard about the generators and motors. What are the generators? Generators means which converts mechanical energy to electrical energy. This is nothing but the generator. Either it may be a DC generator or AC generator, that is the secondary issue. Now, based on what type of electrical energy we are going to get from the generator, that decides whether the generator is AC generator or DC generator. Similarly, we heard about motor. What is that motor? Which converts electrical energy into mechanical energy. Suppose if you want to extract some water from borewells or wells, what happens? We were provided with electrical energy. So if you are switch on that electrical machine, especially electrical motor, electrical energy, it will be converted into the mechanical energy. That type of machines are called as motors. So first, based on the supply, what type of supply you are giving to run that particular machine, or what type of supply you are expecting from that particular machine, based on the supply, based on the nature of the electrical energy, that electrical machines has been classified into 2-6. So first one is the AC machines and second one is the DC machines. So based on the equipment used and based on the orientation of the machines, especially field windings, etc., etc., there are so many classifications are there in the electrical machines. But broadly, electrical machines based on the nature of the supply we are giving to the machine, or based on the supply we are expecting from the machine, these electrical machines have been classified into broadly in two sessions, that is DC machines and AC machines. So DC machines are divided into again DC generators and DC motors. So we know about the generator and we also know about the motor. Now in this sequence of videos, we are talking about the DC generators and DC motors. Now, after completion of this DC generators and DC motor, we are going to talk about the AC machines as well. So, most DC machines are more or less similar to the AC machines, only at the end of that armature. Armature is a device on which that conducting system are going to place. From that conducting system only, we are going to extract the electrical energy generated by the system. So, there will be a rectifier kind of thing, that is nothing but it is a commutator. Now, if there is no commutator, then directly that electrical energy generated across the armature, it will be a alternating one. So, which is nothing but AC machines or alternating current machines. Suppose if the rectifier kind of thing, which is especially it is called as a commutator, if the commutator is connected, what the commutator will do? Commutator will convert alternating quantity into the unidirectional quantity. So, alternating current, either voltage or current, whatever it may be, if it is alternating in the nature, if the commutator is connected to that particular point, then the alternating quantity becomes unidirectional quantity. That is the main use of this commutator. Now, always all the machines, either it is a AC machines or DC machines, whatever it may be, the energy, that electrical energy available across the armature terminals, is always alternating in the nature. Suppose if you are expecting a DC current or DC voltage or DC type of electrical energy, then you had to place a commutator at the end rings of that armature. Then what is that commutator? Commutator is going to convert the alternating quantity into unidirectional quantity. So because of that, suppose if it is a DC machine, commutator is mandatory. Otherwise, what happens? Across the armature, that energy will be an alternating quantity. If it is an alternating quantity, means you cannot run the DC loads. So, moreover, you cannot say that machine as the DC machine. So, if you are expecting that machine, or if you are giving a DC power or DC power you are expecting from the machine, means compulsory commutator should be connected. But the simple reason is all the machines, either at AC machines or DC machine, the orientation, the placing of the field windings and armature conductors are such that the energy across the armature is always alternating in the nature. So DC machine and alternating quantity across armature means something it looks different. So that's why if you are especially if you are seeing DC generator, so we require the DC electrical power. So how can we get the DC electrical power with AC power available across the armature terminals? That is nothing but we had to place a commutator kind of thing. So commutator is basically it is a one type of rectifier, electronic rectifier. So here commutator is going to convert that alternating quantity into the DC quantity. That is not exactly DC, not the purified DC, unidirectional quantity more exactly. So in view of this, DC machines are also called as commutating machines. So okay, we are discussing about what are the types of electrical machines and where exactly these DC machines are used. Now prototype DC machine, now that 5 volts DC machine is shown here in this one for better understanding. That is the only compact one. With the help of this, we can develop some prototype models also. DC motors are everywhere. Not only we cannot restrict the place of the DC machines, and this is exactly used to a particular application. In the majority of the applications, DC machines are widely used. In a house, if you are taking almost every mechanical movement that you see around you is caused by an direct current motor only. So this is a very, very important machine available in the electrical machines. And the advantages of these DC motors is that it is easy to control their speed in wide applications. Suppose speed controlling is very, very important thing, especially in the industry. Now, in which the DC motors are DC machines, broadly, if you can say, DC machines are highly benefitable to control the speed. Because the process, if you want to control or if you want to regulate the speed, the speed controlling mechanism is you can easily achieve with the help of DC machines. So anyhow, in the sequence of these videos, we are going to discuss about the speed control mechanism of the DC machines. There, we can get the good idea what are the important advantages of these DC machines, especially in the speed controlling applications. Meanwhile, please forgive me. While DC motors are widely used, such in aircraft, automobiles, and portable electronics and speed control applications. So, in view of this, these machines are very, very important. Now, in this video session, we are going to discuss about the principle of operation at the beginning. Then we can proceed like we are going to discuss about the various constructional details, application wise, and whatever the various mathematical equations involved in the electrical machines. With the help of that electrical modeling, how we are going to utilize the purpose of these DC machines in various industries and domestic applications. And what are the speed controlling equipment and what are the mathematical equivalent of the speed controlling equations, types of DC machines, and various characteristics in industrial, total load characteristics, open circuit characteristics. All these things we are going to discuss in this video. So what are the basic requirements? This is very, very important because now we are simply saying that if something is kept in the magnetic field, we are going to get the electrical energy. What's that? How it is possible? Now, who has been introduced this means now what are the basic requirement means? First of all, we have to establish a strong magnetic field. Okay, just magnetic field is enough. A uniform magnetic field is required. And one more section is just to take a conductor. Conductor is nothing but it has minimum resistance, internal resistance, and it allows the flow of electrical energy through it. So such type of conducting system you take separately, and at in one hand we are going to establish that uniform magnetic field. In another hand, armature conducting system we are going to take, and you keep one in another. Means suppose now initially if you have been developed with a uniform magnetic field, inside that magnetic field just you keep the conductor. For example, initially let us start with one conductor. You keep the conductor inside that magnetic field. Then the third and one more important point is nothing but you develop the relative motion between the two fields. What are the two fields? One is the magnetic field and next one is nothing but conducting system or conductor. So After keeping one in another, just develop the relative motion between them. Then you can see the beauty across the armature conductor or the conducting system. If you could connect one voltmeter, it will give some deflections. So it is nothing but what are the minimum basic requirements to establish or to generate some electrical voltage. Means first a uniform magnetic field is required, then you take one conductor, and then third important point is just to develop the relative motion between the two fields. Then we can see some electrical energy, it will be available or it will be produced or it will be generated across the conducting system. So these are the three important requirements. Now with the help of these three important requirements, you can generate the electrical energy. That energy, it will be available across armature or conducting system, which is also called as, or which is nothing but relative motion, means which you can keep one as a constant and one field you can rotate. So for example, now there are two sections are there. One is the magnetic field and next one is the conducting system. What is that magnetic field? How we are going to generate the magnetic field? Means very simple. Now you can keep North Pole and South Pole with some mechanical separation. Then between this North Pole and South Pole, you can see some magnetic field. So like that, we can generate some magnetic field, but the strength, of course, it is very essential and important also. How much of magnetic field or what is the strength of that magnetic field is also important. But for basic understanding, the uniform magnetic field is required. It is highly essential, and that uniform magnetic field you can produce by keeping two permanent magnets, that is a North Pole and South Pole. And if you could test the field available between the North and South Pole, now you can ensure that existence of the magnetic field. That is the one thing. Second one is the conducting system. You take a copper wire or the conductor which allows the electrical energy through it, or which allows electrons through it, which is nothing but the conducting system. You take based on your requirement one conductor, two conductor, of course. Now let us start with one conductor, and okay, inside one, now we are going to keep one another. Suppose here this is the North Pole, just excuse me, this is the North Pole and this is the South Pole. This is the North and this is South. Between them, there is a magnetic field. So, of course, that magnetic field, let us assume the direction of the magnetic field is like this. So, I am taking a conducting system. I am going to place the conducting system like this. So, inside that magnetic field, just to keep the conducting system. So, after that, now if you are developing two fields such like this, now we cannot see anything. But the important point is nothing but you have to develop the relative motion, not just motion, relative motion. Means with respect to one, another has to rotate. That is the meaning of the relative motion. So here both the fields you can rotate, or you can keep one field as a stationary, another field you can rotate. So based on the requirement or based on the facilities available, you can achieve any one of these two methods. So in order to simplify the principle of operation, what I am doing is North Pole and South Poles, which is nothing but that magnetic field I am going to assume as a stationary. So that magnetic field I am assuming as a stationary. So that is nothing but the stationary magnetic field I am producing. And next one is rotating conducting system. Means I am going to rotate this conducting system by placing a prime mover or by placing a turbine or anything. Just one handle kind of thing you can connect here, and with the help of this particular handle you can rotate in any one of the direction based on your requirement. So if you are rotating in the clockwise direction, what happens? This conducting system also rotates in the same direction. So that is the way how we are going to develop the relative motion between the stationary magnetic field and rotating conducting system. Once the conductor starts rotates, then between these two terminals, let's assume this is the side A and this is the side B. If you are connecting a voltmeter between the side A and side B, now you can see some voltage. What do you mean by that? That is nothing but some amount of voltage, it will be generated or it will be produced inside the conducting system. So what is the reason behind this? Means this was proved by Faraday's scientist. So this is nothing but Faraday's laws of electromagnetic generation. So these are the basic things, how this magnetic field it can be generated here. That is a permanent magnet or electromagnet. And electromagnets means by allowing some current through some conducting system. Now generation of magnetic field is nothing but the electromagnets. And electromagnets, of course, these are very compact in size. Suppose if you want to generate huge amount of magnetic field, a very highly strengthened magnetic field if is required, means with the help of this permanent magnet, what happens, the size of the magnet is also proportionally increased. Then only you can develop some highly strengthened magnetic field, otherwise not possible. So that is a very difficult thing. Now if you are doing the construction of this any electrical machine with the help of these permanent magnets, then size also matters here, because strengthened magnetic field means the size of the permanent magnets also proportionally increased. So if the permanent magnet size increases, the size of the electrical machine also increases, which is not advisable. So that's why permanent magnets are going to replaced with electromagnets. Now what is the difference between this electromagnet means? On a piece of iron or on any magnet, some amount of turns we are going to wound by allowing some current through that conducting system. Now you can develop huge amount of magnetic fields. So that is nothing but practical magnets, which are nothing but the electromagnets. So like this, we are going to develop a magnetic field. And one more thing is nothing but a conducting system. Preferably copper is used. Otherwise, if you want to reduce the weight of the machine also, aluminum bars are also advisable. So these are going to place on the, so generally conducting system is nothing but, now if you want to place more number of conductors means we are going to take a cylinder kind of thing. Now on the outer surface of the cylinder, we are going to place some conducting conductors. This is one conductor, this is another conductor, another conductor, another conductor, like this. So on the cylinder, on the outer periphery, we are going to place various armature conductors. So this armature is nothing but, what is that armature? Which is a rotating body, which carries conductors. Now that is nothing but the armature conductors. So this armature is nothing but it is a rotating body. Simply we can say that armature is nothing but it is a rotating body. Now it carries the conducting system. So that conducting system may contains few number of conductors. Now who will decide the number of conductors means that will be based on how much of electrical energy you are expecting from that will be decided by them. Okay, so that conductor or conducting system, that is nothing but the armature. It will be it is going to carry copper wires or aluminum wires. Now which one is preferable means, now if weight is not a matter, then copper is highly preferable. If weight is also important, if you want to reduce the weight, aluminum is preferable. So every material has its own advantages, merits and demerits and limitations. So based on your requirement, you can choose a suitable material to construct or to choose the conducting system. So third one, very important point is relative motion. Now that relative motion you can achieve by connecting a prime mover or IC engine or turbine, is nothing but just whatever it may be. This is nothing but one handle kind of thing. So based on your requirement, you can rotate the conducting system either in the clockwise or anti-clockwise. Now this example we have taken by assuming stationary magnetic field and rotating conducting system. Vice versa also you can choose, so that it will be highly useful in the AC machines. In the AC machines, what happens, stationary conducting system we are going to assume, and magnetic field is nothing but it is a rotating, because in the AC machines the electrical energy, expected electrical energy from the machine is very high. So that's why if you want to see a huge amount of electrical power, more number of conductors are required. More number of conductors means if you are keeping that huge weight, the conducting system weight on a rotating body, now sometimes we cannot reach the rated speed. So in that cases, it is better keep the conducting system stationary and rotate, because ultimately what we require, only relative motion is required. The relative motion you can achieve like that also. So just now also we have discussed what made the electrical energy. It will be generated across the armature conductor. So it's nothing but who has proved that means Faraday's laws. There are few laws are there. First law, second law and Lenz's law is also there. So when the armature is rotated, means armature is always rotates. So this is a conducting system is rotated in the magnetic field, and induced voltage it will be generated in the armature conductors. So electromotive force, which is nothing but EMF, is equivalent to the voltage. So this EMF is nothing but it is going to generate because of cutting of magnetic flux lines. Now whenever that armature conductor or conducting system is going to rotate in the magnetic field, there will be a cutting of magnetic flux. That cutting of magnetic flux will produce some electromagnetic force. So EMF So that EMF is nothing but it can be formed by what is the direction of voltage. So whatever the direction of that EMF, so what are the polarities of that voltage, it will be generated in the armature conducting system. Now that we can find out with the help of Fleming's right hand rule. These are all these things we are going to discuss now. So what is the first law of this Faraday's law? So whenever the magnetic flux linked with the circuit changes, an EMF is always induced in it. So don't confuse with this. Whenever a conductor cuts the magnetic flux, just now also we have discussed, an EMF is induced in that conductor. That is the first law of Faraday's law. And what is the second law? The magnitude of the induced EMF is equal to the rate of change of flux lines. So that EMF is directly proportional to the magnitude of induced EMF is equal to the rate of change of flux lines. So that is nothing but d by dt of flux linkages. So flux linkages means n is nothing but number of turns, pi is nothing but the flux. So as per the second law, what happens? This magnitude is nothing but n into d phi by dt. What is this n here? This is nothing but how many number of turns or how many number of conductors you have kept there. So that is nothing but the n, and pi is nothing but the magnetic field or the strength of the magnetic field is nothing but the flux lines. So this is the first law and second law. And one more law is there, that is nothing but Lenz's law. The direction of induced EMF in a coil is such that it always opposes the cause of producing it. So what is the cause? So the generated EMF always in the direction to the opposing to the cause. So that EMF was generated because of what? So that EMF once generated, this acts in the opposite direction to the cause. That's the meaning of this Lenz's law. So with the help of this, we are going to identify the direction of that EMF, whether it is aids to the cause or opposed to the cause. If it opposes the cause, then we are going to keep negative sign, otherwise positive sign. So here, one more important thing. Now with this simple GIF, I am going to analyze here a changing magnetic flux through a loop or loops. Now you can see here, this is the voltmeter where we have connected here. So this is the loop. This is nothing but it is a loop. In this one, what happens? This magnetic flux I am allowing to move horizontal direction towards this loop or far away from this loop. What happens? Proportional to this, you can see some deflection in the voltmeter, which is nothing but what is the one? This is a simple experiment or simple setup now which demonstrates very well the induced EMF depends on how many parameters. So if the cutting of flux lines are more, then EMF is also more. If the cutting of flux lines are less, cutting of flux lines with whom? So here the loop is nothing but this is the loop with shown with this black color. This is nothing but the loop. Now whenever this magnetic field is close to this loop, means huge amount of cutting is taken place. So there we can see maximum amount of induced EMF. Otherwise, once this magnetic field is moving away from the system, then less amount of induced EMF, sometimes zero also. So this is the brief introduction to this. Now I hope you enjoyed this video. Thank you very much. Thank you for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.